Today I want to talk about chapter 3. In this chapter, I discuss the CNS statement, mathematical expressions, data type conversion, and typecasting. I want to discuss overflow, underflow, name constants. So in this chapter, it discusses the CN object. We say the CN is the standard input object. It's like cout. It requires the IO string. With CN, we can get something from the keyboard. It's used to read input from keyboard. When you want to use a CNS statement, we use the double right arrow. Data is retrieved from the CNS statement with double right arrow, the stream. We call this double right arrow stream extraction operator. Input data is stored in one or more variables. So let's look at this example. We have int height, which height is an integer variable. With cout statement, we display this message. How tall is the room? When you have a text, it goes in double quotations. I say C and double right arrow height. With cout, we can display something. With cn, we can get something from the user. This variable height is integer. When you have an integer variable, it can be a number like 1, 23, 67. If you want to store that number inside the variable, we can say C and double right arrow height. So the user input goes from the keyboard to the input buffer. We have something in the computer's keyboard, which we call the buffer. Buffer is a memory that can store some characters. We can say that the CN converts the data to the type that matches the variable. When you use the C and double right arrow height, the computer is expecting an integer variable. If you put something other than integer, it will get converted to an integer data type. In this example here, we're using the CNS statement to get multiple values. We say CN double right arrow high, double right arrow red. So with one CNS statement, we can get multiple variables from the user. If you want to get them, we separate them with double right arrow. Multiple values from the keyboard must be separated by spaces or enter. So after you put the data, you have to either hit space or enter. For the last value that you put, we hit enter. Multiple values need not to be all the same type. You can have different data types when you use the CNS statement. The order is important. The first value entered is stored in the first variable, and then the second one goes in the second variable, and so on. You could write mathematical expressions in C++. We say an expression is something that can be evaluated to produce a value. For example, 2 height, A plus B divided by C. These are expressions. It can be a constant, a variable, or a combination of constants and variables combined with operators and grouping symbols. We could create complex expressions using multiple mathematical operations. When you have an expression, the expression will get evaluated to something. For example, in this example here, A plus B divided by C, whatever you have in the A, B, and C will get calculated. The result will get evaluated to a value. We could use mathematical expressions in C++. They can be used in assignment statements with cout and other types of statements. In this example here, we say area equal to 2 times pi times radius. This is an expression. After the expression, we put semicolon. So we say cout border is double right, double left arrow, 2 times L plus W. We have two different expressions here. 2 times pi times radius, 2 times L plus W. So this border is with double quotations is also an expression. When you have an expression, it gets evaluated. Whatever you have in the parentheses gets evaluated first. We have something that we call an order of operations. In an expression with more than one operator, we evaluate it in this order. We first evaluate parentheses. Open, close parentheses, they have the highest order of operation. Second, after that, we have negation. which is an order from left to right. Then we have multiplication, division, and modulus, which they are getting evaluated in order from left to right. Then last, we have plus and minus, which they get evaluated in order from left to right. For example, when you say 2 plus 2 times 2 minus 2, the multiplication happens first. It gets evaluated first. 2 times 2 becomes 4. Then we have a plus and we have a minus. Since plus and minus, they are in the same order, they get evaluated from left to right. First, this plus gets evaluated and then minus. You can see the order of evaluation is first multiplication, then plus, and lastly, minus. Sometimes we have negation. Sometimes we have multiplication, division, modulus, plus, and minus. Sometimes you have parentheses that can be used to override the order of operations. In this example here, 2 plus 2 times 2 minus 2. First, multiplication happens. 2 times 2 becomes 4. Then we have plus, and then we have minus. Since plus and minus, they have the same order of operations. First, plus happens, and then minus. We get the result of 4. 2 plus 2 times 2 minus 2. Since 2 plus 2 is in parentheses, it will get evaluated first, which is 4. 4 times 2 becomes 8. 8 minus 2 is 6. 2 minus 2 in parentheses, it gets evaluated first, which is 0. 0 times 2 becomes 0, plus 2 becomes 2. 2 minus 2 is 0. 0 times anything is 0. You can see that when you have several operators together, parentheses has the highest order of operations. It happens first. After that, everything gets evaluated based on this order. We have negation, multiplication, division, modulus. We have plus and minus. If several of them happen together, the one on the left-hand side gets evaluated first, and then the one on the right-hand side. We could write algebraic expressions in C++. Multiplication requires an operator, which is this. This operator is used for multiplication. When you say area equal to L times W, we could write it as area equal to L times W using the multiplication. If you want to calculate the area is S to the power of 2. We can say area is POW S, 2. This POW function is a function that finds something to the power of something. Like if you want to find S to the power of 2, you can use the POW function. In order to use the POW function, we need to include the CMAT library. POW requires the CMAT header. Parentheses may be needed to maintain order of operations. For example, if you want to find y2 minus y1 divided by x2 minus x1, we need to use parentheses because the parentheses has the highest order of operations. If you want to write this expression, you can use parentheses, say y2 minus y1 divided by x2 minus x1. In C++, we can have data type conversions and type casting. Operations are performed between operands of the same type. If operands do not have the same type, C++ will automatically convert one to be the other type. This can impact the results of calculations. When we talk about casting, it means we want to convert something to something. We have two different types of casting in C++, which I will discuss them. We have different hierarchy of data types. You can see that the highest hierarchy is with the long double. Then we have double, then we have float, unsigned long, and long, and. The lowest rank here belongs to integer. These are ranked by the largest number they can hold. The higher ranking the data types are, they can store larger numbers. We have different types of casting, which we call a type coercion. Coercion means when you convert an operand to another data type. We have either promotion or demotion. Promotion means conversion to a higher type. Demotion means conversion to a lower type. We have some coercion rules like character short, unsigned short, are automatically promoted to integer. When operating with values of different data types, the lower rank one is promoted to the type of the higher one. When using the equal operator, the type of the expression on the right will be converted to the type of the variable on the left. These are the coercion rules. So if the motion is required by equal operator, the stored result may be incorrect if there is not enough space available on the receiving variable. Floating point values are truncated when assigned to integer variables. Coercion affects the value used in a calculation that does not change the type associated with the variable. So these are the rules that we need to follow, we need to consider when we have coercion. If you want to convert something to something in C++, you can use the typecast. The way that we can cast something is using a static underline cast. When you say a static underline cast at 4.2, it means I want to convert 4.2 to integer. This statement is telling the compiler that I want to convert this 4.2 to this data type, which this will display 4. For example, if character ch is equal to c, if I say cout ch is stored as a static cast as ch end, this will display the character, which is c, and then it will convert it to integer. And it will display the integer variable for character c, which is the ASCII code for character c. If you write gallons equal to a static underline cast and area divided by 500, area divided by 500 will get calculated. It will get converted to integer, and then it goes in this gallons. If you say average equal to a static underline cast, double sum divided by count, you will convert this sum to double, and then you divide it by count. You put the result inside average. So in C++, we have two different kinds of casting. One of them is implicit casting. One of them is explicit casting. Implicit casting means when the computer converts some data type to another data type. Explicit casting means when you tell the computer to convert some data type to another data type. Older typecast styles were double value equal to 21.58. Int val1, int val2. When I say int val1 equal to int value, this is the C-style typecast, which will convert the value from double to integer. If I say int val2 equal to int, open parenthesis value, this is the pre-standard C++ style typecast, which will convert the value from double to integer. So we can say that the C-style cast uses the prefix notation. This is the older types of casting. So if you want to use cast in this class, use a static underline cast. A static underline cast will convert one data type to another data type. How you can do it? Like this. You say a static underline cast, you put whatever you want to convert inside parentheses, you put the data type that you're converting to inside the brackets. We have overflow and underflow. Overflow happens when assigning a value that is too large or too close to 0, which that is underflow. So we have two different things, overflow. Overflow means something, you're putting something inside a variable, but that number or that variable, it couldn't hold it. So it's too big. Underflow means when you're trying to put something inside a variable, but that is too small that it couldn't fit there. That is underflow. It happens both with integer and floating point data types. In this example here, we create a short integer, which is initialized to the largest value it can hold. I say short int num equal to 32,767. I have a short integer. When I say cout num, it will display 32,767. If I say num equal to num plus 1, I will add 1 to my num. When I say cout num, it will display minus 32,768. You can see in this example, when I add 1 to my short int, it becomes negative. which we call this overflow. It means the maximum number that the short end can be is 32,767. Anything larger than that, overflow will happen. So the question is how we can handle overflow and underflow. Different systems handle the problem differently. Sometimes we can display a warning or error message. Sometimes we can stop the program. Sometimes we can continue execution with the incorrect value. So depending on what you want to do, how you want to handle the overflow, underflow, you can either put an if condition. If this happens, then do something. Or you can display a warning, or you can stop the code from running, or you can continue. But if you continue running your program, it will execute with the incorrect value. In C++, you can define constants. We call them also constant variables. When we talk about the variable means something that can change. The variables whose content cannot be changed during a program execution, we call them constant variables. They are used for representing constant values with descriptive names. If you say const double tax rate equal to 0.0775, you have defined a constant double. When you define a constant variable, you need to initialize it. We will often make them uppercase. Like in this example, the tax rate is uppercase. The num underlying states is uppercase. So we have some rules we need to follow when we define constants. The value of a named constant must be assigned when the variable is defined. If you say const int class underline size equal to 24, I'm defining a constant integer, which the name of that constant integer is class underline size. I'm putting 24 inside it. If I say class size equal to class size plus 1, I'm trying to add 1 to a constant, which that is wrong. So if you run this code, you'll get an error. An error happens if you try to change the value stored in a named constant after it's defined. You couldn't do that. So when you want to define a constant, we have a keyword, which is const, which is used to define a constant variable. You put the data type, you put the name of the constant. It's good to make the name of the constant capital, and then you have to initialize it. This is how you can define a constant. There are some benefits of named constants. They make the program code more readable by documenting the purpose of the constant and the name. When you say const double tax rate equal to 0.0775, you're defining a constant variable which is type of double. You initialize it with 0.0775. So they can improve accuracy and simplify program maintenance. It's a very good practice to use constants in your program. They improve the readability of your code. If you have something that is not going to change, you can use a constant. We could use multiple and combined assignment. In this example, I say x equal to y equal to z equal to 5. I have multiple assignment. In this example, x, y, and z, they all become 5. This is the same as you say x equal to y equal to z equal to 5. First, z becomes 5, then y becomes 5, then x becomes 5. The first equal that happens is the one on the right. Then y gets the value, then x gets the value. We call this multiple assignment. Sometimes you can have combined assignment, which applies an arithmetic operation to a variable and assigns the result as the new value of the variable. For example, plus equal, minus equal, multiplication equal, division equal, modulus equal. These are also called compound operators or arithmetic assignment operators. If you say sum plus equal AMT, it's a short for sum equal to sum plus AMT. We have plus equal, minus equal, multiplication equal, division equal, modulus equal. X plus equal 5, it means x equal to x plus 5. It's the same code. X minus equal 5 is the same as x equal to x minus 5. X times equal 5 It means x equal to x times 5. X division equal to 5. It means x equal to x divided by 5. So these combined operators, they are the shorthand for the same operator. Like if you want to add 5 to x, you can say x plus equal 5. If you want to multiply x by 5, you can say x multiple equal 5. The right-hand side is evaluated before the combined assignment operation is done. For example, when you say x times equal a plus b, this means x equal to x times a plus b. So these two expressions are the same. First, a and b they get added, then it gets multiplied by x, the result goes inside x. You could format your output based on size, position, or number of digits, which requires the IOM IP header. We could control how output displays for numeric and story and string data. We have some functions that are defined in IOM and IP. We call them stream manipulators. They are used to control features of an output field. One of the functions that we have is setW, which will print a value in a field of at least x, spaces wide. It will use more spaces if the specified field width is not big enough. It right justifies the value if it does not require x spaces. The decimal points in floating point values use space. All characters and string, including space characters, use space. So with setW, you can create a box. Then you can put something inside that box and display it. We have some stream manipulators, some affect values until changed again, like fixed or set precision. Fixed is what we call it. It will use decimal notation, not E notation, for floating point values. The set precision is used when used with fixed, it will print the floating value using x digits after the decimal. Without fixed, print floating values will be using x significant digits. Rounding is used if x is smaller than the number of significant digits. So we have two different functions here, fixed and set precision, which they use for stream manipulation. We have also show point left and right. The show point always prints a decimal point for floating point values. This is useful when fixed and set precision when printing monetary values. Left and right can left or right justify a value in a field. So if you look at this example here, we have a double constant E, which is 2.718. I have a double price, which is 18.0. When I say Cout, setW8, E, and L, I have a box of size 8. 2.718 goes inside my box. By default, it goes to the right. When I say Cout left, setW8, E, I'm sending whatever I have inside this box of size 8 to the left. It will display 2.718 and it goes to the left. If I say Cout set precision 2, I'm changing the set precision to 2. If I say Cout E and O, I'm displaying the E, which is 2.7, using set precision of 2. It means I will get only 1.7 here. When I type Cout fixed E, it will display 2.72. With fixed and set precision, you can specify exactly how many decimal numbers you want to, how many floating point numbers you want to display, how many floating point digits you want to display. So when you say set precision 2 fixed E, you get exactly 2 decimal points, which is 7 and 2. If you look at this 2.718, after 1, we have 8. Since 8 is greater than 5, this 1 will get rounded to 2. If you say Cout setW6 price, the price is 18.0. It gets displayed 18.00, and then there is a blank space here. It means it goes to the left. So with this left, you're sending that number to the left. If you put right, you can send it to the right. By default, it goes to the right. With setW, you can create a box, and then you can display that variable inside that box. When you want to work with characters and strings, we say a character holds a single character. A string holds a sequence of characters. Both can be used in assignment statements. Both can be displayed with cout and double left arrow. In this example, I'm defining a string. This str is a string. When I say C and double right arrows str, it reads in a string with no blanks. When I say get line C and comma str, it reads in a string that may contain blanks. If you want to get a string from the user that there are no blanks inside it, you can use a CNS statement. If you want to read a string that it can contain spaces, then you can use getLine. In this example here, I'm defining a character ch. I say C and double right arrow ch. This reads any non-blank character. When I say C and dot get ch, this can read any character. When I say ch equal to C and dot get, this can read in any character. Sometimes you want to read a character that could be blank. Sometimes you want to read a character that is not going to be blank. If you want to read any non-blank character, you can use the CNS statement. If you want to read a character that could be blank, then you can use this get function. How? By saying ch equal to cn dot get. This ignore is used to skip over next character in the input buffer. With the ignore function, you can clear the buffer. Buffer is the memory that your keyboard has. If you want to clear it, you use ignore. So we say the cn ignore is the way that we use it is cn dot ignore n comma c. N is the number of characters you want to skip. C is where to stop when the character is encounters. If it stops, if C is encountered before N characters have been skipped. Otherwise, N characters are skipped. We could use a cn dot ignore to skip a single character. So with this cn dot ignore, you can clear the buffer. If you want to clear a single buffer, you can just say cn dot ignore with no arguments. If you want to ignore some characters until you reach a specific character, you can use cn dot ignore n comma c. We have some string member functions like linked, which it will indicate the number of characters in a string. When you say string first pairs equal to George Washington, we're defining a string, which it contains George Washington. If I say in size equal to first pairs dot length, size is 17. With the length function, you can find out how many characters you have inside your string. Length includes blank characters. It does not include the null terminator, which is \0. With assign, you can put repeated characters in a string. It can be used for formatting output. When you say string equals, you're defining a string. When I say equals dot assign, AD equal, I'm putting AD equals inside my string. If I say cout equals, it will display AD equals. If I say cout total, and then I display the total, it will display the total. So with this assign, you can assign something to a string. When you put what number you put here indicates how many of these characters you want to repeat in that string. Assignment assigns a value to a string. When you say string words, you're defining a variable words, which is a string. If I say words equal to tasty, I'm putting this string inside my words. With plus, you can join two strings together. If I have string is1, which is hot, and is2, which is dog, if I say string food equal to is1 plus is2, the food becomes hot dog. It means with plus, we can attach and combine two strings together. The plus equal concatenates a string onto the end of another one. Words plus equal food, words becomes a tasty hot dog. With plus, you can attach strings together. With plus equal, you can do the same thing. We call this concatenation, which means putting strings together. We could use a C strings in C++. A C string is stored as an array of characters. So the C string is actually an array of characters. The programmer must indicate the maximum number of characters at definition. It means when you want to define a C string, you have to indicate how many characters you're going to store in that C string. So a C string is an array of characters. When you say constant size equal to 5, you have a constant integer, which is 5. When I say chart temp size equal to hot, I'm defining a C string of size 5. The null terminator is placed after final character to mark the end of the string, which you will get HOT_0. The programmer must make sure that the array is big enough for desired use. Temp can hold up to 4 characters plus _0. Since the C string is size of 5, it could contain 3 characters. It can contain 4 characters and null terminator, which is maximum of 5. The null terminator will take a character in memory, which each character is 1 byte. In this example, I'm reading in a C string. I say constant size equal to 10. I have a constant integer, which is 10. I say char CSTR size. I'm defining an array of characters, which the size is 10. When I say C and double right arrow CSTR, it will read in a C string with no blanks. It will write past the end of the array if the input string is too long. When I say C.getLine CSTR comma size, it will read in a C string that may contain blanks. It ensures that less or equal to 9 characters are written. So C strings are array of characters. You could use a CN to read a C string that doesn't have any blanks. You could use getLine to get a C string that could contain spaces and blanks. You can also use the setW and width to control input fields widths. The setW string manipulator can be used with CN as well as the COut. When used with the CN and target C string array, setW limits the number of characters that are stored in the array. In this example, I say const in size equal to 10. Char CSTR size. CN setW size the CSTR. In this example, I'm using this CN and the setW to limit the number of characters I can get and store in this C string. If you look at this C string, the size is 10. It means it could contain maximum of 9 characters. With cn.width, you can also provide this limit. When I say cn.width size, cn double right arrow CSTR, I'm getting something from the user. I'm putting it in my C string, but the limitation that I have is specified with width. It means that's the maximum number of characters I can read, which is 9. You could use a C string initialization and assignment. A C string can be initialized at the time of its creation. For example, const in size equal to 10, chart month size equal to April. I have a constant integer, which is 10. I'm creating a C string of size 10. I'm putting April inside it. A C string cannot later be assigned a value using equal. You must use the strcpy. When I say chart month size, I'm creating a C string of size 10. When I say month equal to August, I'm putting this August and I'm trying to put the August and month, but this is wrong. If you want to initialize a C string, you will use the strcpy, which is a function that copies this August inside this month. With strcpy, you can copy and fill content of a C string. CN can be used to put a single word from a keyboard into a C string. The programmer must use the cn.getLine to read an input string that contains spaces. So in this example here, we say const in size equal to 25. Chart name size. I have a C string of size 25. I'm asking the user, what's your name? I say cn.getLine name, comma, size. So this getLine function is used to get something from the user, and you can put it in a string, or you can put it in a C string. If you're dealing with C strings, then this is how you do it. You say cn.getLine name, comma, size. Note that the cn.getLine is not the same as getLine. We have some mathematical library functions that require CMAT header file. They take double argument to return a double. Some commonly used functions include abs, sine, cosine, tangent, sqrt, log, and POW. abs is used to find the absolute value of something. We have sine, cosine, which you had those in your math classes. You could use these functions, which are defined in the CMAT library. You could define and create random numbers in C++. You could define random numbers in C++, which is a value that is chosen from a set of values. Each value is a set that has equal likelihood of being chosen. Random numbers are used in games and simulations. In order to create random numbers, we use the cstdlib header file. We have two different functions here, rand and srand. Rand returns the random numbers between 0 and the largest integer the computer holds. It will yield the same sequence of numbers each time the program runs. The srand will initialize random number generator with unsigned int x. X is the seed value. This should be called at most once in the program. So with the rand function, you can create a random number, which is between 0 and the largest integer your computer can hold. If you use the rand several times, you will get the same set of random numbers. In order to get this different random numbers, you need to use the srand, which you will pass a seed to it, which is an integer. This x is a seed. This seed will make the rand function to produce different set of random numbers. We can use the time to generate different seed values each time that the program runs. We have a library, which is a seed time. You can say hashtag include seed time, which is needed for time. If I say unsigned seed equal to time 0, I'm calling the time function, I'm passing 0 to it, which will give me an integer. I'm passing that integer to the srand to trigger the rand to give me a different set of random numbers. The random numbers can be scaled to a range. For example, I can say int max equal to 6, int num equal to rand modulus max plus 1. This code will produce a random number between 1 to 6. With this modulus max, I can specify the range that I want to get. With plus 1, I can add 1 to it. When you divide a number by 6, the remainder of division will be 0, 1, 2, 3, 4, 5. One of these. If you add 1 to it, you can go from 1 to 6.